Hello, so this is the fourth session where we're building up to A2 market structures and theory of the firm work. We've already looked at revenue and how we plot revenue curves, and we've also started to look at market structure. And what we're going to look at today is how the market structure and revenue curves are all linked together with this idea of production and costs of production and levels of output. So we looked at this already in the first year a little bit. We're going to have a bit of a recap and add a bit more detail to it now. So I've already explained how it fits in the specification. It fits into the market structures, and the cost curves that we're going to look at at the end of these sessions, together with the revenue curves, will allow you to analyse any of the market structures in the specification for A2. Also, I'm going to talk you through in this session an experiment that if we'd been under normal circumstances in college we would have been doing as a class. So you'll need to be a little bit imaginative and think through how this is going to work. But first thing, we mentioned this already, in economics the short run and the long run is really important, but it's different than it is in business. If you're studying business studies, the short run and long run mean slightly different things. So for us as an economists, short run and long run isn't a very specific length of time, so it's not 6 months or 12 months or anything like that. What it actually is when the firm cannot change one of its factors of production. If that's the case, we say that the firm is in the short run, where one of its factors of production is fixed. The amount that the firm is able to have of it can't alter. It won't be fixed forever. It's just for the time maybe under a contract or the time it takes to build a new factory. In that period, it's fixed. Okay, so as a quick little memory test, there are 4 factors of production. I'm hoping you can remember what they are. They're land, labour, capital, and enterprise. The ones that tend to be fixed more commonly are land, so space or buildings, factory sizes, and capitals, the equipment that goes into them. They tend to take a longer time to increase the size of. If we're able to alter all of those factors of production, and we're not in the short run, we're in the long run. So if we take an example of a factory, if I was able to extend my factory and all the other 3 factors of production as well, then that would be a long run. But once I've built my extension, I've got a new combination of those 4 factors of production, and that becomes a new set combination. A factory extension has been built, but that is it, that's the new size of the factory. Then I'm in the short run again. I've created a new short run condition once that factory's been built. But if I can alter all of them, then I'm in the long run. Okay, so here is the experiment we would normally be doing in lessons. So I'm going to talk you through how this works. All of you know, and hopefully most of you, and ideally all of you, are following the Twitter account that I set up at Priestley Econom. So the scenario goes like this. I'd have the class set up at the front on the desk. We'd have a pair of scissors, a blue felt tip, a biro, sheets of papers with a pre-printed logo on, lots of them that would need cutting out, and maybe a pencil to put punch a hole through the paper. So we've got that equipment, and I asked for a volunteer to come up, and here's the sort of instruction. I need badges to be made. This is the scenario, so I can give out as many badges as I can. So the idea is that I describe exactly what the badge must look like. You must only use the equipment that I've left at the front, and you've got to make as many as you can. Okay, so here is a picture of the logo. So you can imagine a sheet of A4 paper with maybe 25 or 30 of those on. A student sits at the front, they have scissors, felt tip, biro, sheets of these and a pencil. Okay, and I say to them, right, make me as many as you can in a minute, and then we count up how many that is. Then we have the same equipment, and I invite another student to the front. We count up how many are done between them on the second round, and we keep doing that. So we increase the number of students each time, but all the other factors don't change. Okay, so by the end of it, sometimes I've had 10, 11 or 12 students at the front. So I want you to picture that in your mind. Okay, we've got a table with scissors, felt tip, pen, sheets of these paper with these logos on, sorry. There's 12 students at the front. What's going to happen each time I add a student on? What's going to happen to the amount of badges that are produced? Okay, well, what tends to happen and what should happen is that the first student struggles really because they've got lots of jobs to do in only a short length of time. Then when we add the second student in, the output increases. We add the third student in, and between them they each focus on doing a little stage of the task, and the output increases. And that tends to happen until all the equipment is being used. So we've got a student cutting out, we have a student colouring in, a student writing the slogan on the back, and a student punching the hole. So there's 4 students each doing a specific job. But at that point, all of the equipment is being used. So when I add student 5, student 6, student 7, actually there's very little they can do because there's no equipment for them. So think about that, the factors of production involved in this experiment. We've also got the students who are taking the form of the labour. We've got the capital in the scissors and the pens. In fact, all of the factors of production except labour are fixed in this example. I can keep adding more students until I run out of students, but the equipment is all fixed in quantity. And that means we're in the short run. So as an economist, this is really, really important, because what we're looking at is we've got a set amount of factors of production, but we're increasing the number of workers. So can you imagine increasing the number of workers but putting them in an office with one computer and a telephone, or into a set size factory? Eventually the workers will have nothing to do, and they become less and less and less useful or less productive. And that experiment would lead to this really important concept. It's called marginal product, or more commonly we will call it marginal returns. Okay, and what that means, that word marginal, we've met when we talked about revenue before, means the change in total from one more. Okay, how much output does each extra worker add? So we've got this table here. I'm going to fill it in. You can look at it being filled in with me, and then that's going to be the end of this session. I'm going to then record the graph. I'm going to plot the graph for you and put it up as a separate little video. I'd like it if you had a go at plotting the graph if you've got graph paper, or if not, just having a really good think about why the curves are the shape they are. Okay, so here, when we've got no workers, total output product, another word for output, our total product is 0, so our average product will also be nothing, 0. Okay, when we've got one worker, the total product is 4, so that one worker is making 4, means on average it's 4. 2 workers are making 9 between them, so the average is 4.5. You can see how this pattern. 5, and then here we've got 4 workers making 20, gives an average of 5. 5 workers making 24 is an average of 4.8. 6 workers making 26 is 4.3 roughly, I think. 7 workers making 26. You see, the total output hasn't increased there. So 7 workers making 26 is around about 3.8, and then 8 workers making 24 gives us an average of 3. And what you can see going on here, this is the important thing, the average product rises, it plateaus at 5, and it starts to fall back again. Okay, and that matches what's going on in the total output. Look, as we add the first few workers, the output increases each time. Then the workers become less productive, and total output reaches its peak at 26 and falls back. Now that is what sets the marginal product here. The marginal is the change in total. It's written between our number of workers. So from 0 workers making 0, we had 1 worker who makes 4. So the total has increased by 4. Now you note where I'm putting this. It's on the line between 0 and 1 for workers. This would be the x-axis. Okay, then the second worker has increased output by 5. The third worker increases total output by 6. And that's the change in total that I've put in that column. And again, it follows the same sort of pattern as the other 2 columns, where the change in output increases. So the first worker is adding 4, adding 5, adding 6, adding 5. All of these are positive. All these extra workers are adding something to output until we get to worker 7 there. Worker 7 actually doesn't add anything at all. And worker 8 actually makes things worse. Perhaps he's getting in the way, or perhaps that person is just stood chatting and doing nothing or causing problems. But actually, the addition of worker 8 reduces the total output, so the marginal output, marginal product, is actually a negative value. Okay, so what's going to happen next is I'm going to stop this session. I'm going to record a separate video on where I can show you on graph paper what these curves will look like. I want you to make sure you can understand that, and then we'll pick this up and see, well, that's okay, but what does it actually mean in terms of costs? Okay.